We are solving this problem using Newton's second law of motion. For this system, we can use sigma F equal to sigma ma. That is sum of all the forces equal to sum of mass times acceleration of every component of the system, every part of the system. Two masses are involved here. So for the two mass system, so sigma ma involves both masses, mass of the wedge and mass of the small block. Now the wedge has only one acceleration, capital A, marked as capital A to the left, whereas the small block has two acceleration. One is the capital A, that of the wedge itself, because it is moving as part of the wedge. Then small a marked down the incline as the relative acceleration, relative to the wedge. So relative to the wedge, it's moving simultaneously, moving with the wedge. mg sine alpha is the component of the weight of that block down the incline, which is the only external force we require for this problem, which we have to use in this problem. So that gives us the first equation. Then, since there is no friction, according to data, there is no friction. This means there is no chance of any horizontal force on the system. Net horizontal force is 0. Second equation is based on that idea. That is, net force, external force equal 0, but in the horizontal direction, sigma mass into acceleration is used in that equation. So, using two equations, we are able to solve this problem. Now, there is a third force relevant to this system, that is the normal reaction, which is acting on both the small block as well as the wedge, as the direction on the small block upward direction, on the wedge downward direction. We have marked it in the diagram, but we didn't use it. We didn't use that normal reaction in our equations, because in the first equation, down the incline, it has no component. Second equation, since we are taking the whole system, the normal reaction has no part in that, because it's an internal force, can be regarded as an internal force and neglected. So we suppose this normal reaction is included in so it is given in various textbooks. If you include the normal reaction also, then we will require 3 equations. Instead, we have solved the problem with just 2 equations. What we have worked out is the capital A, which is the requirement. That is the acceleration of the wedge. If you want, or if the question, suppose you come across another question where the relative acceleration also required, means you can just substitute force to get the small acceleration. Then the actual acceleration, that is the total acceleration of the small block with respect to ground, will be vector resultant of capital A and small a. That also, if such a question is asked, you can use that idea to get the actual acceleration of the block, because this question can be modified in various forms. So depending on what is asked, you proceed. So from the discussion that we have given, you can find how to get the acceleration of wedge alone if you want, and also how to get the acceleration, relative acceleration of the small block. I think now you can follow the solution as given. Thank you.